So let's start with the first example. This class is all about motivation and giving you the big picture of what this course is all about. So I won't immediately start the core of this course. That I will do from next class or perhaps the end of this class. So let's look at the first example. Okay, so this is something that you would have seen the moment you Google machine learning. There will be examples which are very similar to this. So the first example would be, let's say I want to. The problem is the following. So finding the expenditure of a house. Okay, so what do you mean by this? Well, for example, you go to a house. How do you value a house? On what basis? How do you, for example, if there is a house, what are the characteristics that are proportional to, say, for example, the value of a house? What are the things that you will ask? So, for
Area,
example, okay, so first thing would be area. Fine. Area of
number
the
of
house. Okay, number of rooms. Okay. What else? What else?
Reachability.
Okay, so reachability, you can measure it in different ways, right? For example, you can say the nearest bus stop, right? Distance to the bus stop or something. Okay. Bus stop. Okay. What else? And so on, right? Area means the size of the house. Maybe I'll also write that size. Okay, area could be in which area the house is located, right? For example, if it's in some posh area, the rate could be very high, and so on, right? So these are certain features that will tell us what is the price of the house, right? So you use this to predict the expenditure. Is this fine? Clear, right? It's very obvious thing that anybody will do. So how do you find these characteristics or features? Well, you go to a real estate person and ask him what are the typical things that you should consider in order to predict, or in order to find or let's say not the expenditure. I think, I'm sorry, this should be the price of the house, right? Not the expenditure. Okay, so this will be the price of the house. Well, you can also do expenditure, right? Depending on where the house is located, how many people are there, what is the rent, etc. Right? So that's a different problem. So let's assume we want to find the price of the house. So these are the characteristics, right? So now, what is it that we want to do? If you want to mathematically represent this, so I cannot. Typically, what people do is some of these features, right, need not be numbers, right? It could be, for example, if you want to say what is the area, you would say Jayanagar or something, right? You won't really. There is no number attached to it. So the first thing people typically do is you have to attach a number, right? So how do you attach a number? Maybe you give rating, right? 0 to 1. So 1 means very posh area, 0 means, let's say, some very bad area, and in between, right? So you can use numbers. So essentially, if you collect all these features, what do you get? You get a vector, right? X1, X2, and so on, Xm. So you get M numbers, right? X1 could be the price of the house, X2 could be the size of the house, Xm could be the locality or area, whatever you want to call it, right? So mathematically, you will get a vector, right? So you want to map this vector to, let's say, up the price of the house, right? Let me call Y. This is the price, right? So all that you have to do is, given these M numbers or a vector, you have to find a number called the price. So where this number lies? So this number lies in R plus, right? So that means it's a positive number, right? You cannot say the price of the house is -1 lakh, right? So this is what the task is. Given a vector, I have to find a map F that will give me the number. So basically, if I call this as capital X, F of X will give me a number called the price. So these are called features. So now, of course, this is a big picture of how do you find the price of a house. So suppose, let's say you want a machine to do that. So what is it that you will do? So of course we need to make some assumption. For example, I say that this is the assumption, or this is a reasonable assumption to make. So what is that? Let's say the price is some linear combination of these features. For example, I say y is some w1 x1 plus w2 x2 and so on wm xm. Okay, so is this always true? Can I make this assumption? The price of the house is always a linear combination of the components of the feature vector. Can I make this assumption? Yes or no?
No, sir.
Yes.
No, sir.
No, right? This is in general need not be true, right? Our model assumption is not very accurate. So because of which we always have some error, right? Let me call this error as W. Okay, so this is my error. Error in my assumption or error in my model, right? So, but this is a simplifying assumption, right? So I can just say the price of the house is a linear combination of all the feature parameters plus some noise which will characterize how much I am deviating from my assumption, right? Okay, so now suppose this is the model and I want to find this f, which will tell me given a feature. So what is f now? F will be what? So in some sense, I can call this as my f, right? So this whole thing is f of capital X, right? Can I call this as f of x? So essentially the price is f of x plus noise. Well, I want to find this f, right? But in general, I want to find f that will give me the actual price, but that is very difficult in practice because there is no guarantee it's linear combination. There is no guarantee it's some polynomial combination and so on, right? So always you make a mistake. So let's stick to the simplest possible f that you can have. So this is f being linear, right? So this is a linear f that I'm looking at. Suppose this is my assumption and I want you to find f. So how would you go about finding f? So what do you think is the step that you will, or what is the procedure that you will follow? Yes? Any idea?
We'll do regression. We can do regression.
In order to in order to do the regression, you need something, right? So you do regression on what?
With the cost function.
That is also fine. Let's say I give some cost function and all that, but the first thing that you need is data, right?
Measuring that.
No, but you need some data, right? So you need to find the pattern here, right? So of course linear pattern, but you need more data in order to figure out what will be the pattern. Do you agree? It's good to have more data, right? So anyway, so I can also write this y as follows, right? This is W transpose X plus noise, right? So oh, I think I have used the same. I'll use n here, okay? N for noise. Okay, so this is simpler notation y. So this is all that I'm doing is this W1, W2, Wm, and this is X1, X2, Xm plus one number noise, right? So this is what we have. So now if you have to solve the problem, of course, what is the problem here? The problem is the problem boils down to find W, right? If you find W, you're done, right? You give me X, I'll say W transpose X, that will be my whatever the price, right? So what do you do typically? So what is given? So you are given lot of data, right? So you are given the following data. So let's say you go to house 1, collect all the features, right? Let me call that vector as x1. So x1 will give me the area of the house, the locality, etc. That vector is x1, and also they will give me what is the price. I go to house 2, x2, y2, and so on. I collect, let's say, n data points, right? Suppose. Now, given this set of data points, what should I do? I should find the function f, or in this case, simple linear function, which corresponds to finding w, such that your prediction is as close as to your actual value as possible. So, right, what is the problem that you will pose given this? What is the problem? Given n data points. Suppose, let's take a very general approach, okay? So suppose, let's say f of, I want to find f, right? So f of x1 should give me what? What should it give me? Suppose you're finding a map from the feature to your price. So what should f of x should give you?
y1 minus noise.
House price.
Well, ideally, I want this to be y1, right? Let's say f is designed by God and he knows everything, assuming that is true. Then f of x1 will be y1, f of x2 will be y2, and so on. He will find such an f, right?
Yeah.
Right? But in general, I want f of xi to be equal to yi. Well, is that possible? Not really, right? In practice. So I want the difference to be small. In other words, I want the difference squared to be small for each I. Well, what I will do is I will sum it over all I. Okay, so how many i's are there? I mean, how many terms are there? N terms, right? So I want this squared error term, the sum of the squared errors, to be as small as possible. How do I do that? I'll minimize this overall f. Okay, so this f, right? So what does this give us? This gives us some f star, right? Or let me call this as f hat star, right? It will give me a function which is f hat star if I do this, if I solve this problem using the data. So how do you predict? Or suppose I give you x, how do you predict? Y hat is my predicted price, which is f hat star of x, right? So this is what I do. X is my input, that is the feature corresponding to a new house. Then I will just take my f hat star that I have computed. I'll say f hat star of x, that will be my price, right? Is that fine? Again, recall, this is called a feature, right? Feature vector. Okay, so solving this problem, this problem here is called a regression problem. Okay, this is called a regression problem. Okay, so I'll pause here for some time, maybe a couple of minutes. Any questions?